Princeton is known for its historic architecture. The oldest buildings on campus date back to 1756. So what does the future of architecture at Princeton look like?
You have to have sustainability involved from day one of the process. If you even just go back to when the Lewis Library was built, right? This was about an aesthetic move to have a building that is iconic. And I think there's this really strong push now that it's not really about having an iconic architect alone. But now just as many people come and ask, oh, you have those solar panels on the chemistry building, or don't you have the gray water recycling system, or the gardens, and the identity of the project becomes something beyond fantastic form, but something that's also sort of a fantastic steward of how buildings should act in the environment. On the ceiling, there are passive radiant cooling panels, so the ceiling provides cooling without blowing a bunch of cold air on people necessarily. And by doing that, you can provide that cooling with a lower amount of energy to bring it into the space. So by blowing air through big diffusers, that process usually requires a colder temperature at the core of the system and requires more energy for the fans. And so by using these distributed panels, you can cool the building more effectively. And then all the thermal mass in the building through the stone and materials that are used in the heavy, massive walls that helps make the system more efficient. You also have very efficient distribution of heating systems throughout the spaces, and all the labs, which is the core energy use.
So if you is, compare without a doubt, the most energy-intensive building we have ever built.
Wait, what?
The most energy-intensive building we have ever built.
The vast majority of the energy is due to the fact that you need to change over the air in these laboratory spaces, where you need to have extremely clean air that's exhausted regularly. So you're working on experiments where you want to move the fumes out, and so you need to bring lots of fresh air in to replace those air volumes. And that process requires a lot of conditioning of that air. And that's really one of the big challenges, and where the largest energy efficiency happens is actually in that domain. For example, a typical clean room that may be using the same amount of energy as 20 houses, if we cut the energy of that clean room in half, it's as if we went to 20 people's houses and convinced them to do 20 different things and cut their energy demands in half. So even though the building itself uses a lot of energy, way more than most of the other buildings on campus, the effort has been made, and the engineering and design that went into the recovery systems that recover the heat before you spit out the wasted laboratory air, those things really save substantial amounts of energy. But again, it's always the challenge is that then we have to make sure that in the end we really do value and understand that the reason we're spending all this extra energy, so the building may still use 20 times more energy than one of the academic buildings down the street, we want to make sure that that investment is really leading to development of new solar cells and new technologies that can then, in the end, help to provide that energy in a sustainable way, and also develop the technologies to help mitigate impacts on the environment that are detrimental as well. That being said, we have a long ways to go in how much stewardship happens in every building. None of these buildings are without impact. They're all with significant impacts that we still need to address. I mean, as I've already said, the amount of energy that the labs in both here, Frick, and in neuroscience that the newest building on campus all have huge energy demands that are not at present mitigated. And I think it will be built in to that design process as it evolves as we move into the future, but it remains a significant challenge. And there would be a lot of risk that people are not ready to take. So one thing I always say in architecture, when we talk about building buildings and whether you could actually build the building so that it doesn't have any, let's just say the classic scenario is sort of the zero emission building or the zero energy building, that you mitigate all the emissions, you get renewable energy for everything. But a building is the most expensive thing you can buy. You have to mitigate tons of risk, because it's kind of like going out and buying a car, but you have to like specify every part, and you're not really sure if every part's going to work right. Are you really going to let that guy tell you, like, oh, I'll put this engine in, but I've never run this engine before, but I swear it's 50% more efficient than the other one. So you're buying something that lasts 50 years. It's like the most expensive thing you're going to buy. So it's really hard to get people to do risky things or to try new things. And so it's one of the slowest moving sort of sectors by its own nature. And so for that reason, I could say that I could design this building to have zero energy. The technology kind of exists, it's out there. We could put solar panels and we could change the airflow and do tons of natural ventilation, but people wouldn't be happy, we wouldn't meet the code, so they probably wouldn't let us do it anyway, and then most of it would probably break. But it's a great opportunity to be able to show people, hey, this is what we're trying to push the envelope on, and these are already the cutting edge that you can get on the market, and I can show people, like, this is the next thing we're going to do. I can take a thermal camera around and show them these systems, and then show them the things that I'm working on. It's a really great opportunity to sort of see, okay, this is better than what's in your standard building. Show people that, hey, this is something you can also do in the academic building down the street, and make it, you know, also more efficient. And the engineering that happens is really sort of something that there's a lot of specific efficiencies that can be gained, but in the design process, which is a much larger thing, you go through from the idea of wanting to build a building to actually having something constructed. That's where there's a lot more nuances, and connecting those things is something that we do over in the architecture school, and really try and push the limits there. But in the end, when it comes to the nuts and bolts of the thing, it has to be the engineering and the architects that both understand each other.
So, will Princeton take the risk? The Andlinger Center represents a new direction for campus planning, taking into account questions of sustainability. But there's still a long way to go in realizing this vision for the future.
Later, dog.